So we have a list of tasks. Task 1, task 2, task 3. Each task represented by minimum amount of energy it requires and amount it will consume amount energy. This is a pair of numbers, so for example 3 and 1. It requires you to have 3 points of energy and it will consume 1 point of energy. And we will ask to find the minimum energy you can have to finish all tasks. So when we talk about the minimum to do something, and this grows from false to true, we can do binary search. However, it is not evident how you can optimally spend the energy. So by the binary search, you're declaring that you have some amount of energy across middle, and then you're trying to use it and answer the question, is it enough? But the hardest part of this problem is you don't know how to efficiently use it, because there is some corner cases where the order does matter. So it can be this order, and the main hardness, our main trick of this problem is to understand how to use this energy. Now, I personally didn't get it myself, so I used hints and I used comments, suggestions, and I'll try to explain how I understand it. So we have some amount of energy. It's quite big. Let's assume that it is a big number, and we have some tasks. So the first intuition is, let's try greedy by just taking the max limit first, because we want to use our big number first. So naturally you would want, while you have big number, you try to pass all max limit, all the big limits first. So you're doing sort by minus v1, I would say. V is a task value. But unfortunately this is not enough, because solution is not optimal yet, and the hardest part is that second, you would want to, at these big numbers, these big limit numbers, you want to spend less. So it should have worked to sort by individual v0 and v1 as pair, but it is not. It's instead sorted by v0 minus v1. So this prioritize what you have limit should be big and spend should be small. But it's not the only thing. The third is the difference between them. So let's look at the code. I wrote a simple binary search, and after I put it 0 here, it will pass. It has passed. So inside the binary search I just do simulation. Simulation is just tracking your energy, you're spending it, and you make sure the next have enough energy. And just for the interest, can we actually make them separate? Like, imagine we multiply it like that. Will it pass? No, it's not. So you have to consider the relative order, and I honestly can't understand it yet. So maybe you can. Now let's look at if we know the order, that means we don't have to use binary search. We just do so in this Kotlin solution, I sorted it backwards. So I gone from the end, and I reckon the energy I would require to pass. So from the end I take the value, or if it's not enough, I'm increasing the value by the limit. And you have to do this backwards. So notice this 0 and 1 is reversed. So first is the limit, and I take the smallest limit first, and I take the biggest spend second. Okay, that's it for today.